So, welcome back, friends. Nice to see you back online. And let's have a look at question 23, which was the last one we were looking at yesterday. It's another one involving simultaneous equations. Let's sort of color code it. Let's see if we can make a blue equation with that bit of information. Now remember, this should actually say that it's a geometric sequence. We actually can't do this question without knowing that it's a geometric sequence. Okay, so that's a little thing that we needed to fix. Okay, so T2 is 6. Now remember the formula? The formula says that Tn is a r to the n minus 1. So if T2 is 6, that means that 6 is a times by r to the 2 minus 1. And I hope you're okay with me just doing that in my head. All right, one equation, two variables. Nancy Kinga. We need another equation. All right, T5 is 162. So 162 is going to be a r to the 5 minus 1. There's the second equation. And with these, we can always divide. All right. Now, the easiest way to in fact divide this, all right, is to divide. It doesn't matter which way we divide, but we will get positive powers on the r's if we divide number 2 by number 1. So the bottom one divided by the top one. All right, and we get the a's will eliminate, and we get r cubed. Now 162 divided by 6. Okay, I think it's 27. Let's just have a look at that. 162 over 26. It's nowhere near. It's not over 26. It is indeed 27. All right, there it is, 27. Okay, now we're going to cube root both sides. Remember, cube rooting is the same as raising to the power of 1/3. All right, so we get r is 27 to the 1/3. I just want to make it clear that that's the same as, and this is an exponent rule or a third rule, that's the same as 27 with a 1 here and a 3 here. And that ability to convert from this format, let's just sort of underline them, this kind of green format to this blue format, is going to be very, very important when we get to calculus in term 2. Okay, but for now, either of those, if we work them out on a calculator, we get that r equals 3. And if r equals 3, now we want to try and find out what a is. We get either of our equations. Let's use equation 1. All right, what we're going to do is we're going to write out equation number 1. I'm going to write it in blue again. And I'm just going to fill in the fact that I know what r is. R is 3. Okay, so now a times 3 is 6. Divide both sides by 6. Divide both sides by 3. And I get that a equals 2. All right, I'm not finished. They ask us to find T8. Now T8, we're just going to use our formula for T8. T8 is just going to be a times r is 3 to the 7. Now just be careful here. Do not multiply the 2 by the 3. If you multiply the 2 by the 3, then what you're getting is and then you put it to the power of 7, then you're getting 6 to the power of 7. This is the same as 2 to the 7 times 3 to the 7. That's not what we've got here. We haven't got 7 2's multiplying together. We've got 1 2, Eli Lodwa, and 7 3's. So your calculator will do this correctly for you, but let's just have a look at what it's going to be. It's going to be 2 lots of 3 to the 7. We just type it straight in like that. 2 times 3. Thankfully, our calculator knows that we do the exponent. We do the exponent first. 3 power 7. All right, and there's our final answer, 4374. So T8 is actually 4374. Okay, now you might remember, and we really hope that you do, but with arithmetic sequences, we talked about what we called arithmetic means. Numbers that we will put in the middle of two numbers so that all of them form an arithmetic sequence. What we want to do here is we want to look at geometric means. Okay, so let's take a look. And you might remember what we did is we said, right, there's 11. Now we want to put two geometric means in between there. all right? And obviously what we need to know is what would R need to be, okay? You might see it by inspection, but let's just remind ourselves what we did last time. What term number will this be? This will be term 4, absolutely. And what will this be? This will be A. All right, now in our formula for the nth term, there are 4 variables. And I actually know 3 of them now. All right, we know that 88 is term number 4, which means that 88 must be A, but we know A is 11, times by R, and because it's the 4th term, 4 minus 1, 3. How many variables left in that equation? Eli Lordwa, just 1. Let's divide both sides by 11 and we get 8 is R cubed. And let's cube root both sides, and I'm hoping you might know that the cube root of 8 is 2. All right? Because it's an odd power, it can't be plus or minus 2, just 2. Right, so let's have a look now. What those numbers are going to be, all right, we had 11. Now, if we multiply by 2, and then multiply by 2, and then multiply by 2 again, what we get is we get 22. When you multiply by 2, you get 44. And when you multiply by 2 again, you get 88. And there's the answer. These here are called geometric means, all right? And the reason they're called geometric means is that they go in the middle and they form a geometric sequence. We're going to ask you to pause the video and try number 24 and number 25. Okay, so this one, we're trying to put 3 geometric means between 80 and 5. Right, so we want to put 3 numbers in the middle here so that all of them form a geometric series. What number term is this going to be? This is actually going to be T5, and this is going to be A. And our formula, Tn A r to the n minus 1. So in fact, what we're going to get, 5 equals 80 times r to the 5, T5, 5 minus 1, r to the 4. Now we're trying to solve this equation. What should we do to both sides? To make it a little bit easier, we should divide both sides by 80. When you divide 5 by 80, you actually get 1 over 16. And we've now got r over 4. Just be careful here, because this is an even power. When we take the 4th root, we raise to the power of a quarter, we must remember that we can have both plus or minus. So we've got a 16th, and we're going to raise that to a quarter. Right. When you do that on your calculator, you're going to get a half. But remember, it's plus or minus a half. So let's look at our options here. I'm going to write down 2 options. I'm going to write down a red set of geometric means. If we multiply by a half, positive a half, 80 times a half is 40. 40 times a half is 20. 20 times a half is 10. And 10 times a half is 5. Halala, it all fits in nicely. Cordwa, if r is negative a half, then we get negative 40. But negative a half times negative 40, and negative times a negative is going to be a positive. That's going to be positive 20 again. But when you multiply 20 by negative a half, you're going to get negative 10. All right? A negative number. But when you multiply negative 10 by negative a half, and negative times a negative, you're going to get a positive. You're going to get positive 5. So there are 2 possible answers. Right, let's look at number 25. If you need to, then pause the video again if you haven't tried number 25, or if you want to have another try. Obviously, you can pause the video anytime you like. Okay, but let's have a look. All right, so once again, 3 geometric means. We've got 2, then we've got 1, 2, 3, then we've got 162. Same as last time. I'm not going to write the formula down here. This will be T5. This will be A. All right? 162 is A times R to the power of 4. Okay, now we're going to divide both sides by 2. We get 81. R to the 4 is 81. Let's find the 4th root of 81, but remember, because it's an even power, we could get plus or minus. And so we actually get r is plus or minus 3. And so once again, there's two possibilities here. We've either got 2 something 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 12, and not 12, 162, or we've got 2 something 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 162. And let's see. If r is 3, let's do the kind of the red solution. If r is 3, then these terms will be negative 6. Negative 6 times 3, sorry, it will not be negative 6, it will be positive 6. Positive 6 times 3, 18. 18 times 3 is 54. And 54 times 3, you can check it on a calculator if you need to, 162. If r is negative 3, I'm going to write these ones in green. All right, we're going to get negative 6. But negative 6 times negative 3, positive 18. Positive 18 times negative 3, negative 1, negative 54. And then when we multiply negative 54 by negative 3, we get to 162 again. Okay, just as we did with arithmetic sequences, often we are asked to solve sort of real life examples. Okay, now later this year we're going to do some financial maths and we're going to talk a lot about percentages, all right? But let's just read this question. Money earns 12% interest per annum. If 1,000 Rand is left in the account, how much will it be after 10 years? All right, so what we're going to do, we're going to write down some terms, okay? Now, at the end of 1 year, our 1,000 Rand is going to be multiplied. Let's just think about how, we're going to go a bit slowly here just to do a little lesson on percentages. If we want to grow this by 12%, what we could do is we could find 12%, sorry, we could find 12% of 1,000 and then add 1,000. Now I just want to show you that 12% of 1,000 means 12 hundredths times, remember the word of means times, plus 1,000. Okay, now I want to show you that what actually happens here is that this, if we divide the top and the bottom by 100, we actually get we get 120, all right, plus 1,000. Okay, but I'm actually going to show us another way of looking at this. Okay, 120 plus 1,000, we get 1,120. But before we do that division, all right, let's just have a look. If I took 1,000 out here as a common factor, I would get 0.12, that's what 12% is, and then I'd get plus 1. Okay, so in fact, directly to grow 1,000 by 12%, all I'm going to do is I'm going to multiply it by 1.12. Now this makes perfect sense, all right? Because if we're multiplying it by 1.12, then this number is actually 112%. Okay, we will do some more practice with percentages later, but for now, understand that to grow something by 12%, we find 112% of it. 112%. Now 112% is 1.12, and that's really important that you appreciate that. Okay, so at the end of year 1, we're going to have 1,000 Rand times by 1.12. At the end of year 2, we're going to get that amount, but we're going to times it by 1.12. So we're going to get 1,000 Rand. Now we're going to have 1.12 times another 1.12. We're going to have that. And at the end of year 3, we're going to have 1,000 Rand. And then the amount that we had at the end of year 2 is going to earn interest. So we need to add 12% onto that. We need to find 112% of this amount. So we're going to multiply by another 1.12. What sort of sequence is this? Absolutely, it's a geometric sequence. This is the balance at the end of year 1, end of year 2, end of year 3. We want the balance at the end of year 10. So we want to find T10 of this sequence. All right, now T10 is just going to be A. A is 1000 times 1,12. Now we need to multiply by R. R is clearly 1,12. We can see that to get from one term to the next, we're multiplying by 1,12. So that's going to be 1,12. But we're going to now, if we want the 10th term, we're going to raise to the power 10 minus 1, 9. Okay, we're going to get our final answer. Let's just have a look at what it's going to be. It's going to be 1000 times, now, and I hope you're going to be okay with this, 1,12 times another 1,12 is 9 more of them, so actually 1,12 to the power of 10. Okay, and we get 3105 and 85 cents. 3105 and 85 cents. Right, the next one actually is around something losing value. Right, so just understand this, that for something to lose value, we need to if it loses 8%. Okay, so a thing loses 8% each year. What will it weigh after 15 years if it initially weighs 5 kilograms? All right, now the way we remove 8% from something, when we've got something, let's suppose whatever it is, suppose it's the mouse on my computer, okay, or a cup, okay, or a cup. If we want, this is 100%. If we want to remove 8%, then we are finding 100 minus 8, 92%. So what we're going to multiply by this time is we're going to multiply by 0.92 each time. Right, pause the video, try this question, and then let it play and see how you did. Okay, so after 1 year, we have got 5 kilograms times by 0.92. That's how much of the substance will be left after 1 year. Now that amount reduces by 8%. So we're now going to take this whole number and multiply it by 0.92 to take 8% off it. When we do that, we've actually got 0.92 squared. Now, that's how much we've got after 2 years. You might want to work these numbers out. It might be a little bit easier to understand if you've got actual numbers. You'll see that this is getting smaller and smaller. All right. And now we're going to take 8% off all of this. All of this is 0.92 squared, but to remove 8%, we're going to multiply it by another 0.92. We're going to find 92% of it. Take away 8%, 92% of it. And that's what keeps on happening here. What sort of sequence have we got? Absolutely. We've got a geometric sequence. What's the nth term? AR to the n minus 1. We want to know how much after 15 years. Okay, so we just want to find T15 of this thing. So T15 is just going to be A times by R. Now R is clearly, if we take any term divided by the term before it, R is 0.92 to the power of 14. Okay, right, and once again, let's do that on our calculator. And once again, what I'm going to do, instead of multiplying 5 times 0.92 and then multiplying by 0.92 another 14 times, I'm going to multiply these two bases of 0.92. Remember, when we multiply numbers with the same base, we add the powers. So this is in fact just going to be 15, and there's the answer. It will be 1,431 kilograms. 1,431 kilograms. At the end of 15 years. Okay, we're gonna stop there. We are gonna ask you to try before the next lesson to do 3 more of these, 27, 28, 29, and then we will tackle them at the start of the next lesson. Okay, have a great day.